So let me just reshare, maybe for the sake of those of us who have joined, maybe haven't seen it, but it should be there. Majority of us, maybe for the sake of this, there's only one number. So I think I've shared again. Yeah. So basically our topic for the day is again part of management accounts. And of course, I think the most or the highlight as far as management account is concerned, basically is cost estimation, which I think is again an item that you must have interacted with before. In I think management accounts, when you are doing either management accounts or the advanced management accounts. So of course, it is what is our topic for the day. So in this, maybe in this in this topic, we shall majorly be interested in two techniques of cost estimation. And in fact, even before we go to techniques, maybe someone could remind us what cost estimation is. Maybe someone should remind us what is cost estimation. And of course, then we can now talk about the techniques as we do a past paper question or just an illustration question, just to explain or to just to explain then that which we have. Yeah, so it's basically about determination of costs. And of course, from past activities, we should be in a position to tell that, say we are talking about a school, maybe school X, which say in the whole of last year or the year to date, maybe in January, February to June, it had X number of students. And from the X number of students, there are maybe I can call it lunch costs. So they spend a certain amount of money in order to provide lunch for its students over the 6 months period. So basically, cost estimation is then coming in when we want to analyze the past cost that has already been incurred. And from the past costs, we should be in a position to develop a function. Yeah. And of course, we're talking about a linear function that then is going to help us then moving forward. Say in October, in July, up to maybe the end of the year, we should estimate that it may be over the last 6 years, over the last 6 months, sorry, we had X number of students, we spent this much, or rather we spent Y amount. How much can we attribute to the fixed cost? And of course, how much then are we going to say is variable cost from there? Such that then maybe in the next month of July, August, and maybe September, we can say, if from the previous record, this is what we are realizing, then entirely it means that we should be, maybe if we have maybe 1,000 students, then this is what our expected cost is. So basically, it's more about just the technique of analyzing the past costs that we have. And of course, from there, we should be coming up with the linear function. And from the linear function, we should be in a position to estimate future costs. Usually, it's more of the future costs that we expect to have, and considering a given level of activity. So basically, that is what cost estimation is. And of course, just as Adan is saying, that majorly it's maybe a cost control or a control mechanism that we can then employ to ensure that our costs are well controlled, or just within that which we within the acceptable range. And of course, then if maybe there are instances where you need to have different maybe different maybe interventions that maybe you need to take into account, then of course you can take into account such items as far as then that cost which you've developed is concerned. So basically, that is what cost estimation is, and of course, then it's of course again a tool that can be used for by management in different entities. Because then, if you've known that you're going to spend this much, or your variable cost is this much, then you should look for ways then that you are going to try to regulate your costs. How then are you going to intervene to ensure that your costs are within maybe budgets or even the acceptable levels in an organization? So I hope basically that makes sense. So if it does, then we can move to the next item. That is now the techniques of cost estimation. So of course, the techniques again, unfortunately, I have already shared the two that we will going to discuss. We're going to majorly talk about the two, high and low method, and of course, regression analysis as a tool of cost estimation. So we are going to start from high and low, then we discuss that. Then of course, again, we look at our regression. As of course, again, as a tool. So what is high and low method, or what does this approach, or rather, how does this approach basically work as far as cost estimation is concerned? So maybe we can have our discussions from there. How does this technique work? What is it? What is this technique? And of course, then we can do an example on the same. So maybe someone to remind us what what high and low method of cost estimation is and what it involves. So maybe someone can remind us. So basically, I'm seeing here that basically we need to yes, I think yeah, that basically explains it all. That for high and low method, we'll be interested in two items. And maybe even before I describe the items, we have these two words, which I've seen we've used them in that explanation: the independent and the dependent variable. Yeah. So basically, we should be looking at our independent variable, and of course, we'll be interested in the highest independent variable and the corresponding cost. Of course, if you talk about in a month, maybe you had 200 students, which was the highest, then ordinarily we expect our costs to be the highest in that particular month. We don't expect maybe a month where we had 50 or 100 students to go higher or to have higher costs than the month that we had the highest. So basically, when we talk about the independent variable, then basically it's that item that it's standing on its own. It does not depend on another. Take, for example, the cost we will incur to feed 100 students basically depends on the number of students, or the cost of feeding students depends on the number, but the number does not depend on the cost. Yeah, you can admit up to 200 students, and of course that will be your cost driver within that particular period. So basically, for high-low method, just as the example I was giving, where we had our students from January to June, then we should be looking at what was the highest number of students that you had in any given month. What is the highest number? What was the highest number? And of course, what was the highest cost and cost. So what was the highest number? And of course, what was the highest cost? So basically the two go hand in hand. What was your highest number? And of course, what was the highest cost that basically you realized or you incurred within that specific month? And of course, again, what was your lowest? We can call it the lowest or the least. So what was your lowest number of students you admitted against the corresponding cost? Yeah. So basically that is how that then come into play. Your highest and the lowest. And of course, we should be comparing the two items. And of course, it's basically these two items that we are going to use for our decision or for us to derive a function. And of course, I've talked so much about this linear function. So we have this linear function that we are going to develop at the end of the day. So maybe even before I proceed, I want us to do a graph. Of course, it's going to feed into our discussions here. I'm looking at the best tool that I can use to draw. What draw? Hmm. By the way, I used to draw kitambo, but I've forgotten. Um, how can I draw a straight line? I'm looking for ways of drawing a straight line without using this tool we have here. Fine, you'll just allow me use this that I have. Okay. So you'll pardon me. I've forgotten how to insert a straight line. But of course, basically, our graph should take this approach. Hope you are going to understand that I'm not very okay. I think I've succeeded. Yeah, I think this is okay. Yeah. So let's assume, I think this is a little better. Yeah, so let's assume this is our graph. Hope you're going to understand that I'm struggling a little bit. Okay, so I think this is better now. So basically this is our graph, and of course on this we have the y-axis on that end. And on the vertical and not horizontal, we have the x-axis. So basically we have the two axes that we basically use. So usually our y-axis should be having the costs. So our y-axis should be having the costs. Then our x-axis has the level of activity. So basically, one thing that you can observe from this graph without having any in-depth analysis is that our line or our graph does not originate from the origin. Our graph does not originate from zero. Yeah, I hope that is something we can all see. And of course, it's this that yeah, our graph does not originate from zero. And maybe I hope you know why it's not originating from zero. And maybe even before we talk about that, we have the linear function. Usually our linear function is y is equal to a plus bx, yeah? So usually this is the standard linear function that we have. So you have linear function should be y is equal to a plus bx. And of course, we've talked about all these techniques still trying to get us close or get us to a linear function that needs to be developed. But then we are saying that this is the structure. And of course, we need to define what our variables are. So we have our y. I think I should have talked about this first before we drawing the graph. We have y being our cost. We have a being the fixed cost, FC. We have B here. We have B being the variable cost. So we have B, the variable cost. And of course, we have X, which is the units. Maybe I can call it slash level of activity. So basically, we have those three items. So back to our graph. In this graph of ours, we have this origin where we are seeing that our line is basically not starting from zero. And the reason being, and sure, maybe that is something we all know, that is because we have what we are referring to as the fixed costs. Basically, our fixed costs, regardless of our level of activity, even if we are not to produce anything within the month, or we were not to have students as per our illustration, still there are costs maybe related to the kitchen that still we would incur. Maybe an example of that cost would be maybe the space for the kitchen. Yeah, the space for kitchen is maybe a fixed cost. It does not depend on the number of students. So we could have a number of, we could be having a number of fixed costs that basically would be incurred regardless of whether we have admitted students or we have not admitted students. And of course, to feed into what we have, this should be our fixed cost. And of course, our fixed cost, we have it at the, we call it fixed cost. And of course, it's also the y-intercept. That is the fixed cost stroke the y-intercept. Yeah, I hope that is clear because it's basically the point at which our line then crosses the x-axis. It's the point that it's crossing our x-axis. And of course, basically that is the point where we are realizing or where we get our fixed costs basically from. Then, apart from that, we have, maybe for those of us who can remember from 2 months, from 2 mathematics, we are talking about something to do with the gradient. Yeah, you remember the gradient of a curve slash the slope. So we can either call it the gradient or the slope. So as part of our items that we've chosen the highest and the lowest. Then in our graph, we should be having the corresponding cost at this particular, at the corresponding cost as far as the lowest level of activity is. Yeah, we should be having our corresponding cost, maybe at this particular point, the corresponding cost of say the least. Yeah, so the least equal hapa. Basically, the corresponding cost should be here. And of course, that should be the least cost, the highest. And of course, our highest level of activity equal hapa with the corresponding cost being here. So what in short are we saying? That if you were to get the slope of between your highest and the lowest level of activity, then we could be talking about two things here. We call it the change in y over the change in x. I hope we can remember that at least. That we had something we were calling here the change of y. This should be the change of x. We had here the change of x. Alafu hapo tuko na the change of y. So basically we have two items here. And I hope you are going to understand in as much as my X and Y are looking anyhowly, but it's still fair enough for our explanations. Basically, when we talk about the change in Y over the change in X, then we are trying to arrive at our gradient or our slope. Yeah. And of course, we are basically again saying, then of course, we are also saying then that our change in Y or the our change in Y, so maybe I can just type it here. Our change in Y divided by the change in X, so change in Y divided by the change in X would basically be giving us our gradient or slope. And of course, I hope we know what the gradient is, and we appreciate that basically our change in Y over change in X would be giving us our variable cost, the VC. So usually, or basically from this, we've arrived, or because of course now we have our variable cost, and of course we have our fixed cost. So that is in a nutshell how then we can model our high and low method. Then we can, so that then we can have our function. And of course, as I've said, basically the entire reason or the entire problem we are trying to solve is then to be in a position to come up with a model that of course would help us then of course that would help us develop a function that we can use to predict further costs. So any question from there? So usually after getting your gradient or the slope, then from there you now go and feed into your variable cost, and you pick either the highest or the lowest and substitute so that you can get your X. Because in most cases it's usually not it's usually a little bit difficult to get your variable or your fixed cost of, maybe unless you do a graph. But of course, if you were to do it mathematically, then you'd say you know what your Y is. Your Y is the corresponding cost. Mary is writing on my screen. Someone is writing on my screen, seriously. Yeah. So basically, we are saying that after getting your variable cost, which of course is quite easy because just looking at the change in Y over the change in X, then we can substitute so that we can arrive at our fixed cost. How? We know our Y. Our Y is, say, for the highest level of activity. We realized that we spent 20,000 in a month, yeah? And maybe even before I do that, if you were to get our A here, see, we could make A the subject of the formula. Our A here, I'm seeing, would be Y minus BX. So is equal to Y minus BX. Meaning if we were to get our A, then we are talking about the Y, which is maybe the cost of the highest, say 20,000 as we were saying, minus B. What is our B? Our B is the variable cost. Say you've gotten your variable cost to be 5 shillings each. X is your corresponding number of units or the number of students within that particular month. So say it was 50. So you spent 20,000 feeding 50 students, but of course the variable cost was 5. And of course we are saying this variable cost should be as a result of your computation. And your Y is also just what you can get right from your function, your linear function. And of course, your 50 is now also the X, the number of units, which of course is coming from either the highest or the lowest. And of course, you need to be consistent. If you've chosen your highest to be your reference point, that needs to be the way all through. If you've chosen your least to be the level, to be your reference point, of course, that is what you need to use all through. Then, of course, from this, you can get your variable, you can get your fixed cost. Meaning then, our function can now be complete. Tutasema Y is equal to A. A say it is 10,000. I'm sure here tutapata maybe, let me say 10,000 minus your variable cost, which is 5x. And of course, with this function that we now have, we can proceed to even estimate further costs of other students. Say then you are interested in finding the cost of even 1,000, of admitting even 1,000 students, or even of admitting maybe 500 students. Then you basically what you need to do is to substitute your X with the number of students you are admitting in this particular school, or with the level of activity then that you are engaged in. So basically, after getting our function, then we can estimate any other cost that may come our way by simply substituting. Any question after that, as well as high-low method. Question, clarification? If there is no question, then it means we are okay with that explanation. So we can do an example for illustrating that which we've discussed before we move to the next item. So maybe I'll propose one of us to read for us. Maybe I can choose today. Yes, Winnie Achieng. Winnie Achieng, can you read for us? The Chebatok, sheet 4.
Okay, thank you, sir. The administration of Chebatok. I hope I'm audible.
Yes, you are.
Kindly confirm. The administration of Chebatok Hills Hospital would like to establish a cost formula linking the administrative costs involved in admitting patients to the number of patients admitted during the month. The admissions department costs and the number of patients admitted during the last 8 months for the year 2017 are given below. So we have the month, which is May to December. Then we have number of patients admitted. And then we also have a column for admission department costs. That's it. So required number 1, using the high-low method, estimates the fixed and variable components of admission costs. Number 2, using the least square method, estimate the relationship between number of patients admitted and the admission costs in the form of y equals to a plus bx. Number 3, using the relationship obtained in B2 above, estimate the admission costs incurred in January 2018 if admission was 2,000 patients. Thank you.
Thanks, Winnie. Sorry for choosing you out of 90 plus students that we have. So thanks for that. So basically, of course, what we're being asked is to develop, to use the high-low method so that then we can develop a function in the form of y is equal to a plus bx. And of course, basically that is where we are going to feed our fixed cost and our variable components. So of course, just as we had said, then that we are interested in what would be our high and of course what would be our low. Yeah, so basically that's what we need to know. So how would we determine our high? High fits into what function? Maybe a function that we can use. I don't want us to look at it from with our eyes. Of course, if I'm to look at it with my eyes, I can see that it is June. But maybe in another instance, you may have a number of items that you need to consider. It's just in order for you to use this function that I've seen there, the max function. So maximum of the number of patients, maximum. And of course, for low, we are talking about the minimum now. So what was the minimum number of patients that were admitted in this particular hospital within those 8 months that we are talking about? So it's basically high and low. And the same would proceed to even our admission department cost. What was our highest cost? And of course, what was our least cost? So that's very important. What was our highest? And of course, what was our least? Good. So I hope we all have that so that we proceed. So from here, can we determine our variable cost? What did we say about our variable cost? Tulisema variable cost is determined from change in y over change in x. That is actually the first approach. Maybe I'll also talk about how we can get it without going the long way. So what is our change in y? So basically our change in y is change in the cost. Yeah. So of course our highest was 15,200 and the lowest was 12,000. So basically that is our change in y. We divide by change in x. 1,900 minus 1,100. And you should be having your variable cost from there. That's how we get our variable cost. Unless maybe one of us is getting an error. So our variable cost is basically 3 shillings. So change in y, change in x. Very straightforward. Very straightforward when looking at our change in y, which is of course 15 minus 12, over our change in x, which is 19 minus 11. And of course, from there you can get the results. Then alternatively, we can also talk about the slope as a function. So we can also have slope as a function. Yeah. So slope is also a function because, of course, you remember when we were talking about variable cost, we said it could be the gradient or the slope. I think you remember that discussion that we've just had a few minutes ago. So if you use the slope as a function is equal to slope, then it's asking us basically just two things. Basically asking us only two things. One is our known y's. What are our known y's? Our known y's are only two from our sample size, the highest and the lowest. So our known y's we know are the costs. Those are the dependent variables. Comma, the known x. Our known x is 19 and 11. Yeah, 19 and 11. So basically, that is how we can use that slope as a function. Of course, again, they arrive at our variable cost. Of course, the result will be the same. It's still 3. So it can't really go overboard. Good. So we can look at our fixed cost determination. So we had said that for our fixed cost, we can substitute, yeah? We can substitute for us to get our A. So of course we say that A is basically is equal to Y minus BX. But of course it's all from our previous discussion, the discussion we had in sheet 1. So basically for us to get our A here is equal to Y. So we say we can either choose to go with the highest or the lowest. Huh? So we can choose to go with the highest. So that in order, we can choose to go with the highest. So our Y, we can choose the highest. Of course, our Y will be 15,200 minus B. What is our B? B is our variable cost, which I think we've already, which we've already, oops, where are we? We are at fixed cost. Yeah, so we've said it is the variable fixed, our total cost of 15,200 minus the variable cost of 3 times the corresponding number of units. And of course, we said if you decided to go with the highest, everything revolves around the high. If you decided to go with the lowest, everything would be with the lowest. So our Y is 15,200. Our B we've already calculated as 3 shillings each. And of course, our number of units we already have as far as the high is concerned. So that then we have that particular model or our fixed cost, sorry. Yeah, so we have the and 9,500 is our fixed cost, which I think majority of us are getting. Alternatively, you remember when I was referring to at the point in which that line cuts our y-intercept. You remember the word intercept. So we also have an intercept function alternatively. And of course, if you have the intercept, it calculates the point at which a line will intersect the y-axis. So we have the intercept. One of my favorite topics is usually management accounts. Sana cost estimation. It's one topic that I really enjoy, apart from group accounts. So this one is usually very, very sweet and of course very easy. So our intercepts, non-wise, again, our non-wise is these two, comma, our non-x, the other two. And of course, you need to define what your y's are, your x are. Otherwise, if you do vice versa, then you may not have the right results. So from here, we can develop our function to say y is equal to A. A we already have as 9,500 plus B. What is our B was 3x. So basically that is our linear function from that particular result or from basically the data that we have. Any question up to there? So maybe a quick question as a follow-up. We can do question 3. We can estimate the cost of admitting 2,000 patients so that we have results. We can try to estimate 2,000 patients, the cost. Maybe someone is asking us how we've gotten it. I think we had that discussion here, how we would get our A. So I think if you are keen here, then it shouldn't be a challenge getting it from the data that we have. The only thing we said is that you need to talk about what your Y is. What is our Y? Our Y was 15,200 minus BX. What was our B? B tulisema ni the variable cost. Our variable cost is 3. What is the number of units for the high? 1,900. See, X tulisema ni the number of units. I think that was our position earlier. So of course, still that is what we would have. As far as that is concerned. So of course, we've said apart from doing it directly with this revised function, then we can, with making A the subject of the formula, we can also do it using the intercept as a function. And of course, the intercept, I think it was asking us the non-y's and the non-x. And of course, our non-y's are 15 and 12. Non-x is 19 and 11. And of course, I've seen a number of us, we are getting the same results. So let me assume that is the correct position of 15,500 as that. So of course, you just need to substitute. You replace X with the number of patients that you're talking about there. Yes, so we can talk about the second item, regression analysis. So maybe we spend a minute to relax a little bit. Then we proceed in 4 minutes. Yes. In the meantime, you can, I think we are proceeding in 2 minutes. We're taking a short commercial break. Maybe if you have a question we can address. Okay, I think that was okay. So for regression analysis, so basically for regression, then regression basically our work will majorly come into in interpreting the results. So basically, Excel, we would feed in the data that we so far have. From the data that we so far have, Excel would run that analysis for us, give us the results, and it's basically now us to interpret the results. And of course, as I've said, and repeating again, that of course the major aim or the main aim we have as far as this whole process is concerned is to develop a function or a linear model, y is equal to a plus bx. So basically from the results that we so far have, we need to interpret it, come up with a function from that result. And of course, maybe the difference between regression and high-low method is that regression now takes into account all the data that we so far have. All the inputs that we so far have are basically taken care or taken into account when using regression. So basically, when using regression, we have everything being taken care of, as opposed to high-low method where we're only interested in the highest and of course the least levels of activities. So how do we do it? Cool. So basically, maybe you can check as part of your data tab. We have the home, insert, draw, then we have data. Confirm if you have a data analysis tool. Data analysis is a tool. I think it's in the farthest end. If it's appearing. Otherwise, if it's not, then we can talk about the procedure of inserting it. Good. So we can, I'm sure a number of us do not have it. I'm almost sure. So we can insert it. We can insert it. So it's usually just an add-in, that an additional tool that we can add. So, and please be careful, be attentive. So click on file. File, we have file at the last, I think the tail end. So click on file. Then you have this, as if you want to, you have that appearing. So click on file. After you've clicked on file, you have this window appearing. Then you click on options at the last. So click on options. For those of us who don't have options, I think you click on more than options. It should be appearing. So click on options. After clicking on options, you have this window again appearing. Then what we want to do is basically to add additional features to our Excel screen. So you'll maneuver till you click on add-ins. So click on add-ins. It should be, I think, the second last. So click on add-ins. I think we have general, formula, data, up to all those. Then you click on add-ins. I think it's the second last. After clicking on add-ins, at the tail bottom end where my cursor is, there is that manage Excel add-ins. So basically we need to manage our Excel add-ins. So manage Excel add-ins. So basically if you click on it, there are a number of items, but currently we are interested in the Excel add-ins. So after that you click on go. So click on go hapa. So manage Excel add-ins, just to ensure it is Excel add-ins. Then you click on go. So go is to tell you what we need to add. Then you check your add-ins available. Then you click on the analysis toolpack. So click on Excel toolpack. And not Excel, but analysis toolpack. Then okay. So ensure that box is ticked, then okay. Then you click okay. So please confirm now if you have your data analysis tool appearing. Otherwise, if not, repeat the same process.
And that is to say, this is a first that our MPP therefore having this is going to be got it right, then everything will change. So because here you can see.
So we can proceed. So just quickly to mesema file options, then add-ins. Yeah, so files, options, then add-ins, then from there. So files, options, add-ins, then we have that add-ins there, then you click on manage. So you are managing Excel add-ins. Yeah, so we have this there, then you click on go. Then you just ensure that your analysis toolpack is active. It's activated by ensuring it is marked. Yeah, then okay. So that's what I want us to use. So you click on that data analysis. So if you click on data analysis, there are basically a number of items that come with data analysis. We have a number of analysis tools. There are so many, but in our today's class, and of course, as far as this topic is concerned, we are only interested in regression. So click on that regression. So you click on the regression and confirm you have that window that I have there appearing. So from there, we have the first items that we need to have is input. So we have the regression, then it's asking us to input. So we need to input the Y range, input the X range, and those others that follow there that we are going to discuss shortly. So we can input our Y range. So basically, we know what our Y is. I think we've discussed that over and over. We know what our Y is. So our Y range basically is our admission department costs. So basically, your admission department costs are your Y range. And of course, we are also seeing, I've selected including the label, yeah? Then a numeric data in admission department cost in shillings. I've also selected that intentionally, such that then when the results would be flowing in or would be processed, that label is maintained. So we have the Y range. So basically our Y range is the cost. So we're starting from the title and the corresponding amounts as our Y range. Then X range, input X range. So again, for X range, the same thought process, our number of patients admitted all the way to the last. So basically, those are our Ys and our X, the first thing that we basically need to have in mind. Then, so basically after identifying our X and the Y ranges, we have those three other boxes that are following. So we have the labels, confidence levels, and the constant is 0. All those that are following there. So mark you, when we were selecting our Y range, we selected plus the label. or plus the title, yeah, in layman's language. So basically, in our labels, we need to define that indeed the first cell that we selected is basically not a numeric data, but it is an numeric data. And of course, it is a label. So usually, after selecting your labels, you have to ensure that that is selected, such that then Excel would interpret that the first cell, as per what we've selected, is a label, is an numeric, data. So that needs to be selected. That labels. Then again, there may be instances where you are told that your confidence level should be a particular percentage. So maybe for the questions I've seen, usually the confidence level is at 95. For a number of questions I've seen, the confidence level is usually at 95. For a number of them, unless otherwise, but usually it is at 95 for most cases. So you need to ensure then that your confidence level, if it is 95, and of course that is not, it doesn't have to be that way. Fact mine has also disappeared. It doesn't have to be a 95, but we are saying if it is given to be 95, then you need to ensure that that 95% is selected. Otherwise, if you told it is maybe 75, then you only need to adjust that figure that you have in that particular bracket. So those are the most important things. Your Y range, you select your X range, ensure that you've selected your labels, and maybe just to mention, the labels should be one cell, one unmerged cell. Meaning if I had maybe row number 5 and 6 merged and having the title, then I'd have to readjust that again, such that then it is not merged and the data is in basically just one cell. And after the title, immediately after the title, you should not be having a space here. It should be the title, the first digit or the first data up to the last one following in that particular order. So basically, if I was to select downwards up to the last, then my interpretation or the interpretation of Excel would be that even that blank there is maybe a part of the costs that were incurred. Maybe there is a year you also operated and you have those. So just ensure then that there is no existing or there is no space between your label and the first data. So the other things that we have is that output options. So usually for output options, then we need to define where we want our results to appear. Where do we want our results to appear? So we have like 3 of them. One of them, we have the last one, new workbook. So I hope we know what a workbook is. Yeah. So that would be a completely new Excel. If maybe that is how we want our results to be shown in a different Excel. New worksheet would basically mean that apart from the sheet 1, the sheet 1 we have an additional sheet, say sheet 5 or sheet 6 that would have results. So basically the results when we select a new worksheet would be that the results are in a different sheet. Maybe in our sheet 5 appearing additionally. Then the first one is asking us the output range. So usually we need to define what our output range is. Yeah? And how do we define our output range? Output range. So if we are to, as part of output options, to say maybe we are using the output range, then in real sense it means one, we want our data, our results to appear in the same question or in the same sheet that we are currently using, but from a particular cell. So usually I do recommend we do it in the same worksheet, maybe just starting from a particular cell. So you select of that output range, then from there you select the cell from which you want your data to be appearing. So you select the particular cell you want your results to start appearing. Good, so we can proceed. So after defining where you want your results to start appearing from, then we need to talk about the residual as the last item we have in there. So usually for residuals, it's more about graphing. Or it's usually about the graph that we want to appear as part of those items that go hand in hand with our results. Huh? So we have, I think we have up to 4 graphs: the residuals, standardized residuals, residual plots, and the line fit plot. So usually, in most cases, you may be asked any, but I want us to use this last plot that we have, the line fit plot that we basically have. Output tumesema, we are talking about the output range. Tumesema for my case, it is B23. That is where I want my results to start appearing from. So it will appear downwards. So output range, that is where you select and you say you define the cell. So for residuals, we are saying it's usually more of the graph that we want. So for the graph that are appearing, we are saying we want a line fit plot to be our graph that would accompany our result. So we'll also explain that graph shortly. So ensure that you have the actual line fit plot. Then, of course, from there, you can talk about, okay, you can click OK. So you click OK. So if you click OK, you should be having an output there. Please not having results so far. So maybe for those of us who are also doing research, I remember when I was doing my project, I had to use a tool here. Was it SPSS? SPSS? Yeah. And even I could do it using Excel. But of course, I think that is maybe something that we can also learn in the process. So please confirm that you have results. I think I've been quite slow on that procedure. So in a minute, maybe you can just finalize if you haven't. Quickly in a minute, so that we proceed at 40, so that we explain the variables and of course try to relate it to the equation. Then we stop at that point. So we can discuss the results. So as part of your assignments, you discuss this result here. Yes, discuss what multiple R is, what R square is, what adjusted R square. In fact, all those variables. The only one that I can talk about is the observations. So basically, observations is this. We had how many months? Our data, the data we are analyzing is for 8 months. Meaning, if maybe we are getting our observations at 7, then it basically means maybe there is an item that we've not taken into consideration. So we need to take care of that. Same as ANOVA, you just look for maybe for your own good, look at how it is interpreted. But for today, I'm be interested in basically these two. Yes, these two last items. So remember we were talking about all this process is to ensure that we arrive at a function, a linear function, y is equal to a plus bx. I think that is our major aim. So of course, how would we get our results? Y is equal to a plus bx. So if we are saying y is equal to a plus bx, then one, we need to define two items, variable cost and fixed cost. So if you look at this coefficients column, hope it is a column, we have the two. We have the intercept and the number of patients admitted. I hope currently, as up to this point, we know what intercept is. Intercept tunajua ni fixed cost. Meaning our function would be y is equal to the fixed cost of 99.48 plus 2.6x. Is that true? That is our function. So basically, we picked it direct from the coefficients. With our fixed cost being 99.48, number of patients being 2.6. Then, remember we were talking about a confidence level of 95%. Whether this is our function, I think from this function, you should be in a position to estimate other costs. Maybe cost of admitting even 2,000. But usually, if maybe you've summarized it as this, I do prefer you don't type the fixed cost manually. You simply link so that you get more accurate results. So you simply link both. Yeah, so that you get more accurate results. So I was talking about the confidence number of 95. The confidence level of 95%. So basically, if your confidence level is 95%, then your analysis would give you two items. One, the lower 95, two, upper 95. So in other instances or in other questions, I've seen maybe where we are also asked to include values of higher 90, upper 95 and lower 95. So basically in that cases, then we are talking about an upper 95 and lower 95. Then it basically means now our So when we're talking about lower 95 and upper 95 results, then it will basically imply that your fixed cost would be as per the lower 95 intercept, variable cost as per these. So in such instances where we're also asked to include results of lower and upper 95% confidence level, or a particular confidence level of maybe 75% and whichever, then basically you need to ensure then that these are also part of your items. So that then now your function would change to y is equal to a of 73, b of 0.97, x. So that would be your resultant function. So I think that explains everything that we so far have. Then lastly, I want us to look at our residual output, then check on our graph. So basically our residual output, you see we have observation, predicted admission department cost, and the residuals. And of course, maybe this is where that label that we are selected comes into play. Such that then when you are doing your results, then it gives you those labels over and over. I only said if you are now solving a real problem, not here, it can't link. This is something I'm writing manually. Maybe if you are asked to estimate 2,000 units, it would be 99 plus 2.6 times 2,000. This is what I meant. Not like here, you can't, here you have to type it manually. Yeah, yes. But maybe if you're estimating costs of a given number, then you'll have to, it's more accurate if you link. Yeah, so in my residual output, it's basically talking about that predicted admin department cost. And basically the predicted admin department cost is coming from the model, or rather the linear function that we so far have. Meaning it's like recomputing what would be the cost of admitting 1,800 patients, but as per the linear function that we have. Say, for example, if you want to test the first one, what would be the cost of admitting 1,800 patients? It would be 1,800 times the variable cost, which is 2.6. Yeah? Then plus the fixed cost. Now, basically, that is as per our computation. So that's the result that you should be having. 14,711, which of course is equal to what we have. So basically the predicted admin department cost now tries to use the function that we've developed to estimate or to recompute the total cost, the total amount of money it would cost for us to talk about admitting this number of patients. So we talk about 1,900 patients, then basically we are only replacing our X, but basically in the same with the same results. Of course, that is the argument. For all items. So in fact, even if you are to estimate maybe for the 7 observation, that is for sure it is maybe 1,100, you should be getting your results as 12. So basically it's just a recomputation of those costs, but based on the coefficients that we so far have here. Then lastly, you can minimize your window so that we see where our graph is. That graph usually, you may need to minimize your window first before you see where it is actually. Yeah, so usually this graph, now basically it's still the same thing. Talks about now the actual costs against the predicted, just plotting, giving us plots of what our cost or of how our graph would be if we now compare the actual and of course the predicted admin department costs, which we've explained what it is all about. So basically it's just showing what is the cost that we initially had and what is that we have now today. What is it we had initially? What is it we have now? As far as basically now graphing is concerned. Yes. So basically that is the most, I think I've touched on all items that we need to know as far as cost estimation is concerned, interpreting the results, using the results that we so far have to estimate maybe a given number of costs and all that is involved therein. So of course, as part of your question, all these other questions are the same things that we've discussed. So please try to look at them as part of your revision. And of course, maybe as part of a topic that maybe you are going to look at your free time is break-even analysis. Yeah, so break-even analysis, please also check on that as part of our management accounting. So please check on cost estimation. Then as part of financial accounting, maybe there is something small we've not talked about. Analysis of financial statements. Majorly using ratios. Huh? Yeah, so you look at ratio analysis and that cost break-even analysis assignment for you. Yeah. So unless there is a burning issue, basically that marks the end of that topic. That is what entirely we need to know. And of course now just trying to interpret that which the items that we basically have as far as these items are concerned. And of course, as part of, again, your assignment, regression. Try to look at what is multiple R, what does R square try to explain, what is this that adjusted R square, again, tries to explain. Because you may be asked, interpret your results. How are you going to interpret your results? If you cannot interpret your regression results if you are not comfortable in particularly explaining the 3 items. So basically that marks the end of that. Unless there is a burning question, we can stop there. We meet on Saturday at our normal class time. Yeah. So I think so far, maybe just to give an overview of the items we basically have left, majorly we have budgets, tax, and group accounts, and of course theory, which are the major items that we so far have left. So we'll try to rush through them so that then we maybe come next month, we should be done with all that we need to do as far as topic are concerned. Then we can now look at maybe the past topics that we've not, the previous sittings questions that we've not checked keenly. So we stop at that point. See you on Saturday. Bye bye.